So with this, I'm going to introduce now Reed Miller. He's an assistant professor in the Department of Civil and Environmental Engineering.
Well, good morning, folks. I'm so happy to be here. I'm celebrating just over 1 year here as an assistant professor at the University of Maine. I'm at the Department of Civil and Environmental Engineering, but I'm fortunate to have a joint appointment as one of the Green Engineering Materials faculty with the Advanced Structures and Composite Center. So it's been wonderful over the past year to work with Roberto and others in the room, really trying to get this research going. So today I'm going to talk about life cycle assessment, and that's a method we can use to track environmental sustainability. But before we get into the how, I'd like us to start with the why. There's a lot of things competing for our attention every day and competing for our priorities. So why do we as individuals care about environmental sustainability? And if you will, we'll go to the next slide here. If you would please, normally you're not asked to pull out your phone during a talk, but if you would please, head over to this site, menti.com, and it's going to prompt you to type in that code there. I'll just read it out in case you can't. 99157660. And the point here is to really ground us in thinking about why do we as individuals care about preventing climate change and preserving nature. So we're ready to switch over. Oh, one before it. The one before it. There we go. So I seeded one for you there. I think about my nieces and nephews who are ages 4 to 9 right now and wanting them to have, a nature that looks like the one I had as a child. Yes. Yeah, it's the one right on the top of the screen there still. It's 99157660. So we'll just take a minute or two here. Thanks everybody for pitching in. Got some sarcasm in the crowd. Appreciate that. So we've got people thinking about future generations, about nature, about preserving beauty, about protecting wildlife and ecosystems. Yeah, keep them coming. This will be around so you can look at what the people around you are thinking about. So yeah, we need to flourish as society. All right, these are really great reasons. So thanks everyone for kind of grounding us in this understanding. We can switch back to the slides. So this is a little tricky. I've asked a lot of Sean today, so thanks for putting up with this. What I'm going to talk about next is, all right, it's not all doom and gloom, but we do have to recognize that our planet is somewhat of a fragile system that humans are impacting. And back in 2009, these clever researchers at the Stockholm Resilience Institute came up with the planetary boundaries. Who's heard of the planetary boundaries before? Not so many folks. Okay, a couple. Great. As you can see, they're listed here. We're dealing with climate change, biodiversity, ozone depletion, ocean acidification, biogeochemical flows. Think of phosphorus and nitrogen flowing from agriculture runoff into waters. Deforestation, land system changes like that. Using fresh water, aerosol loading. So think of particulate matter in the air that's going to affect public health. And novel entities. There's so many chemicals being introduced that we can't even pronounce, much less characterize what effect they might have on the environment. And so what they've devised here is this planetary boundary saying, okay, there are some feedback cycles that we want to prevent from happening. So to keep our planet stable, we need to stay within this boundary, because once we pass a threshold, there's a possibility that these feedbacks might kick in and make it much harder for us to regain stability. So this will get to a little bit if you're a pessimist or optimist, but if we can go back to our next and final Menti slide, I'm going to ask you, how many of those do you think we've currently breached globally? So of these 9, how many of those do you think we've passed this planetary boundary on? So if you go back to Menti, you'll see the next question pop up. All right, so you just type, I think, slide to the number there, and we'll see what folks think. Just take about a minute to do this. So we're skewing pessimist at the moment. We're thinking that we're totally past these thresholds. All right. Wow, we've got about 48 people participating. Thanks, everyone. This is a good group. 51. Holy cow. So let's see here. We're round about 7-ish, I would say, is around the number that folks are leaning towards. And we can switch back to the slides now. The answer is 6. So pretty close. The hive mind worked. And what we can see over time as they've been tracking them, we can go to the next slide, please. Oh, I have a clicker here. That's right. Is that back in 2009, 3 of the boundaries had been transgressed. In 2015, they tracked another 4th. And now in 2023, we're closer to 6 of them being transgressed. Again, the idea is not the world is doomed. It's we've got a lot of work to do. So I'm inspired by Johan Rockström, who leads this Stockholm Resilience Institute. He gave a wonderful TED Talk on YouTube. You can watch it. And back in 2020, he said, for the first time, we are forced to consider the real risk of destabilizing the entire planet. This is the countdown. And so for the next 6 years, to the year 2030, we must have the most profound transformation the world has ever known. That's a remarkable statement. And so I think my question for folks to reflect on is, now that you know a variety of reasons that you personally care about sustainability, you occupy a lot of roles as individuals and professionally. So what can you do in your roles to take big, bold action now and recognize that the status quo has got us to where we are? And so obviously we're going to need to shift things dramatically. So over lunch, if you need something to talk about, this might be something to consider. So we've talked about the why, and I want to talk about the how. How can we help track this? One of the ways is through a method called life cycle assessment, and shortened LCA. And what it is again, it's a method where we are tracking the environmental impacts across the entire life cycle, like Roberto introduced to us, of a product or a product system. And what we're trying to do is find hotspots along that supply chain. Where are the bulk of those impacts? How can we mitigate them? And the reason that we want to take this broader perspective is to prevent what's called burden shifting. So if we have a narrow focus and say, for instance, I'm focused on, I just want to reduce the combustion emissions that come out of a car. I might focus just on that issue, but then I might result in something that, now I'm going to use materials within inside the vehicle that are toxic or something like that. And we don't consider the ramifications, the unintended consequences, unless we take everything into consideration at the start. So you can think of a lot of examples where that might happen. If you focus too narrowly, you're not considering the potential ramifications. And how we do it, just briefly, is we define a goal and scope, and we say, okay, why are we studying the thing and what are we studying? And then we get to work tracking down an inventory. What is the list of everything that went into making this product across the supply chain? And then we convert that into an assessment of what potential impacts there are on the environment. And we're interpreting these results along the way for applications such as improving products or strategic planning. And it's important in this first phase of goal and scope definition to compare apples to apples. That's what we're trying to do. So consider you would like a beverage to go with you. There's a lot of ways you can convey that beverage to you as a customer. You could have a bottle of glass or plastic or a cup. And then maybe you need electricity, as we all do. You could get your electricity from solar or from a power plant. And what we need to have is a functional unit. So you'll see these within LCAs. This is a key thing to say, okay, I'm not going to compare a really large bottle to a really small one. That doesn't make sense. I'm trying to convey an 8-ounce cold beverage. Let's see which ones can provide that function. Or I need 1 kilowatt hour of low voltage electricity. When we think about infrastructure, we might think, okay, I would like to compare bridge designs. Obviously, if I compare an 8-lane highway versus a rural country road, they're going to have different impacts because they serve different functions. So we need some sort of common functional unit. So we might say, let's look at a 1 kilometer span of a 2-lane bridge with a certain amount of traffic loading that lasts for 100 years. And it gets interesting when we think of other products such as rebar. So it's tempting to say, well, I just want to measure the impacts of producing 1 kilogram of rebar. But then we have to think about the function. The function is to provide strength for reinforcing concrete. So maybe more realistically, you need a stretch of rebar of a certain size, of a certain strength level. And we can compare those apples to apples. The next thing we do, as harkening back to what Roberto was saying, is starting from the cradle, extracting resources. So thinking about fuel, that's all the way back to extracting oil from the well. We're tracking through processing those materials, making the products, and at whatever product you're at, that's the gate of that factory. And then we're tracking the use and collection and disposal. So that's cradle to gate, stopping at where these impacts are embodied through the production. Cradle to grave is the whole way along. So if you hear that term embodied, what's the embodied impact? That's what folks are talking about. What were the impacts that accumulated along the supply chain to make this thing? And now here comes the part where it involves a lot of data. Fortunately, we have databases to help us out, but primary data is the best from industries. We want to look at the transportation that makes all of this happen, all of the energy, all of the water, all of the materials and parts that go into all of these processes. Some of them have direct impacts in terms of pollution to the air, the water, and the soil. We want to look then and say, okay, how do those pollution convert to impacts on the climate? So how many kilograms of CO2 are emitted? How many kilograms of methane? Those have different impacts on the climate. We need to account for that. How about impacts on our ecosystems, natural resources, and public health? So fortunately, this isn't a brand new method. It's been around for decades. There's been a lot of research in this space. It's still getting refined all the time, but we have a lot of solid foundation to work from here. And it's important also to avoid this, what's called carbon tunnel vision. While of course it's critical that we protect climate, we have to prevent burden shifting because we might have a product that has a lower climate impact, but if we don't consider the impacts it might have on other things, we might inadvertently impact those systems instead. So for instance, using data from a tool called NIST Bees, if we look at exterior wall finishes that you might have on outside your house, from the brick and mortar perspective, GWP, or global warming potential, which is a common metric for climate change, if we look at the percentage here, so the highest impact across all of these 5 gets 100%, and then the other impacts are scaled. Brick and mortar's the highest, and then stucco is lower. But then over here on the ozone, brick and mortar is lower and stucco is highest. Obviously, if you choose these other ones, they're lower across the board. So that's part of the consideration. The other more complicated thing to figure out is how much do each of these impacts matter? So in terms of PCRs and EPDs, we have standards for LCA that go across all the sectors. And then, for instance, I bought a blender because I like smoothies. So maybe there'd be a product category rule for blenders so that everyone in the industry does it the same way. And then an EPD is a document that would look for one specific manufacturer and model. So there are databases out there such as EC3, embodied carbon, that help construction firms and engineers find these data. And for instance, here's one for architectural wood products. And you can look and see their results. and then it's compared to others in the sector. There is definitely progress within the composites industry. They've done one for utility poles, and we're working on others, so I'll let Joe talk more about that. And I'll just say briefly that I really think EPDs, because of the growing demand for them, it's a way to spur economic development, and Maine's low carbon products with EPDs could really put us at an advantage there. Just wrapping up, I'll just say that I've got work here. I've got 3 students in the crowd. Please chat to them over lunch, Josephine, Pratiba, and Fatima, that are working on issues like variability in the impacts of these products and working on LCA of thermoplastic rebar and the other composite technologies that we're developing. So for instance, we're seeing that there's a lot of variability in carbon fiber results across literature. So we want to get to the bottom of that. And lastly, I'll just note that we do have a fundamentals of LCA microcredential coming out. So Amanda Collmore in the back is helping out with that. And some folks in the room are supporting that. So if you're interested in diving deeper into this, towards the end of the year, we should have this ready for you, and you'll have some credentials to say, I know a lot more about LCA, PCR, and EPDs. So with that, I'll thank you very much for your time.